Okay, today we're covering volume, and we will review the formulas that you have talked about in the past, and then we will solve some applied problems together. Now keep in mind that volume is now dealing with three-dimensional objects as opposed to the two-dimensional that we have dealt with thus far. The volume, first off, of a rectangular solid is the length times the width times the height. That can also be thought of as the area of the base times the height. Okay, big B stands for area of the base, and I may do that. Sometimes you may choose whichever method you want. But one of the things that you want to keep in mind is when we're talking about volume, we're trying to figure out how many of these little cubes will fit into our three-dimensional figure. So a rectangular solid, as we just said, the volume is length times width times height. If you have a cube, all of the edges are the same, so the length times the width times the height is the side times the side times the side, or side cubed. Okay, now for the rest of our formulas, I'm going to go through. We have a little picture for each one, and then I'm going to fill in the blank, and then we're going to do some problems. So this should go by quickly. The volume of a pyramid is 1/3 big B times h. Again, big B is the area of the base times the height of your pyramid. That goes from the base perpendicular to a point. We have the volume of a right cylinder, which is same thing we had before. It's the area of the base times the height, but our base happens to be a circle, pi r squared, and then we have our height of h. Then we have a cone, and a cone is just 1/3 of a cylinder, 1/3 pi r squared h. And then last we have a sphere, which is 4/3 pi r squared h. Sorry, there's no h there. Just making sure you're paying attention. Just for ah, it's 4/3 pi r cubed. That's your formula for a sphere. Okay. We also have surface area. The surface area is the area of the outer surface of a three-dimensional object. We have a cube, so we're trying to figure out how much it would take to paint that cube. And they give it to you in a formula of 6 times side squared, because each of these sides is the same. They're each a square, so side times side, or s times s, is s squared, and we have 6 of them. Okay, for a rectangular solid, they have given it to you as 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Or, just like I gave you before, there is another formula you can have for surface area, and that is the perimeter times the height plus 2 times the area of the base. And I'm actually going to do one of those with you later on if you want to. Again, you can use either formula, but it is to your advantage to write down the formula and show the substitutions so you'll get it right each time you do it. And then, of course, the surface area of a circular cylinder, we're going around the cylinder, and then we have an area on the top and the bottom. Top and the bottom, 2 pi r squared, and then around is 2 pi r plus your h, or excuse me, times your h in this case. Okay, so in summary, with surface area and volume, remember that volume refers to how much paint goes in the can. Goes in the can. And the surface area is how much, what do we make paint cans out of? Aluminum or soup. You can say soup or paint. Aluminum. How much aluminum is needed to make the can? Sometimes people refer to it the label. So this is the label of the soup can, and this is the actual soup that goes in side. So hopefully that will make it easier for you to remember things. So I have three problems that I want to do that are similar to what you have in your classwork, and this will give you hopefully a point of reference and simplify the process for you. So first off, find the surface area and volume of the figure shown. So surface area, as I said, I like to use this formula, which is perimeter times the height plus 2 times the area of the base. Okay? The hardest part about it is, what is the base? So I'm going to I have to pick a part of the figure, a side of the figure that's got the same thing on both sides. This crazy pen. Wasn't supposed to do that to me. Um, so you can see that this is the front and it's also exactly the same on the back. So this is my base, and I'm actually going to draw it in a two-dimensional. I'm doing the best I can. Might not be drawn to scale. I know this is 5, this is 5, this is 2, this is 4, this is 3, and this is 9. So to find the area of that, I can draw this down, and now I have a square, a 5 by 5 square, so this is 25. And then I have a rectangle, which is 4 by 3, so that's 12, which means that the area of my base is going to be 25 plus 12, or 37. Okay, so let's go put this in our formula. Now, perimeter. Okay, think about your base, and I drew it out here because this 4 is the same thing here, and that's a 2, and that's a 5. So when I'm adding them up to go around this figure, if you'll think about, and get to my highlighter here, let's use this one. I have that side, that side. Oh, I didn't write what that side was. This side is a 3. I have it in my picture. Okay, so let's go back and highlight that. So there's a 3 and a 4 and a 2 and a 5. So those are the same sides that I have written here. So now when I write them, I'm going to write wherever you start, doesn't matter, but notice that I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 sides. So I now know that I have all 6 sides. That's my perimeter. And I'm going to take the perimeter and multiply it by the base, excuse me, by the height. Okay? The height is the distance between the bases. Okay? Here's a base. Remember, it's the front and the back, and the distance from the front to the back is right here. So that's going to be my height in my picture. So that's my height plus 2 times the area of the base, which we calculated right there, which is 37. So add up those numbers. You've got 28 times 4 plus 2 times 37 is 74. When we add those up, we get 186. Now, surface area. Area is always square units, so we're going to have square yards. Now, if you do it that way, it makes the volume quite simple if you use that volume formula, because now I can take the area of my base times the height, because I have a prism here, and the area of my base we calculated was 37, and the height is again 4. So 37 times 4 is 148. We're dealing with volume, and volume is always measured in cubic units because we're trying to figure out how many of those cubes will fit inside of this figure. Okay, the next two problems we're dealing with are more application type problems because that's what we're supposed to be working on, so that you can see how knowing surface area and volume is needed out in the real world, in your house. You have a furnace, and it is designed, you're thinking about purchasing this furnace. It's designed to heat 10,000 cubic feet. And they want to know if this furnace is going to be adequate for a 1,400 square foot house with 9-foot ceilings. So, what I need to do is figure out the volume of my house, and the volume is area of the base times the height. My base is 1,400. My height is 9. So 1,400 times 9 is 12,600. So that's cubic feet. That is actually more than the 10,000 cubic feet of the furnace. So, will the furnace be adequate to actually heat the house? Hopefully you can see the answer there is no, because it's less than what the cubic feet I have inside my house. Okay, very practical problem. All right, so when you get really wealthy, doing whatever you do that makes you happy and in life, you're going to perhaps buy a mansion and have a big circular backyard pool. So our next problem is going to deal with how much it's going to cost to fill that pool. We have a circular backyard pool with a diameter of 24 feet. Humor me, I'm going to draw a circle like this because you don't want to see me. So there's my circle, okay? And I'm going to have a diameter. Let's go through the center. So it's going to look like this. So here's the center. And it has a diameter of 24, so I hope everybody knows that that means this is 12 and that's 12 because the whole thing is 24. Okay, it's 4 feet deep, 1 cubic foot of water. We're going to be using this later on. We're just going to highlight it right now. 1 cubic foot of water has a capacity of approximately 7.48 gallons. And then we have to know that it cost $2 per 1,000 gallons. So we've got to figure out the volume of the pool before we figure out how much water goes into the pool, before we figure out how much it costs to put the water in the pool. So hopefully you got that it's circular and it's coming up out of the ground. So that's a cylinder that we're going to be dealing with. And the volume of a cylinder is pi r squared h. So the radius we calculated was 12. And my height, they told me right here, because it's 4 feet deep, is going to be 4. So when I multiply that out, I get 576 pi, which is approximately 1,809.6 cubic feet. Okay, so now to figure out how much it's going to cost, I'm going to take that and use our dimensional analysis that we've done before. 1,809, that's supposed to be a 6. 1,809.6 cubic feet over 1 times. Now what's highlighted in the pink says that 1 cubic foot, remember I need my feet to cancel, 1 cubic foot has the capacity of 7.48 gallons. And then it cost $2 per 1,000 gallons. That's what's highlighted in green. That allows my gallons to cancel. So you should be able to see, most importantly, what we have left here. The only label I didn't cross out were dollars. So that's what's going to be my answer. But I'm going to have 1809.6 times 7.48 times 2 all over 1,000 with a unit of dollars. And when you put that in your calculator, it's going to give you 27.07. And they asked us to round it to the nearest dollar. So round it to the nearest dollar, it will cost us $27 to fill up that pool, which seems like nothing when we're making our millions. So if you have any questions, be sure to ask me when you're working in class tomorrow or even on these particular problems. See you soon.